this video, we're looking at section 1.02, looking at angle relationships. Our first angle, or angle pair that we're going to look at are vertical angles. These are two angles that are opposite each other formed by intersecting lines. So if I think about two intersecting lines, the angles that are opposite are vertical angles. So the angles I just noted are vertical angles. These are also vertical angles. So they're opposite one another. Now, what's special about vertical angles is that their measures are equal. Next, we're going to look at some more angle pairs, but they're formed by looking at parallel lines intersected by a transversal. So in this image on the right, we have two lines here that are parallel to one another, and then this line that intersects both of them, that's what we call a transversal. Our alternate interior angles, we're going to look at angles 4 and 5, are given here. What's special about alternate interior angles? Their angle measures are equal. Now, it's also true that angles 3 and 6 are also alternate interior angles. Now, when we think about these names, I like to think about them as describing exactly where they lie. So alternate means different. So different sides of the transversal, but they're on the inside of the parallel lines. So alternate the transversal, interior of our parallel lines. We can see that angles 4 and 5 and also 3 and 6 are meeting those requirements. Alternate exterior angles. So now we're on alternate sides of the transversal, but on the outside of the parallel lines. Angles 1 and 8. So here's angle 1 and here's angle 8. Now it also follows that angle 2 and 7 are also alternate exterior angles. The angle measures of alternate exterior angles are also equal. Same side interior angles, same side of the transversal, interior of the parallel lines. So same side, and on the inside, angle 4 and angle 6 are same side interior. 3 and 5 are also same side interior angles. Alternate interior angles sum to 180 degrees. So these angles are supplementary. The last is corresponding angles. Corresponding angles are in the same position when you're looking at the pairs of vertical angles formed by the transversal and one of the parallel lines. So angle 2 corresponds to angle 6. Now it's also true that 1 corresponds to 5, 3 corresponds to 7, and 4 corresponds to 8. So there are 4 sets of corresponding angles within this figure. Corresponding angles also have equal measure. So knowing these properties, these special angle pairs, can help us find the values of certain angles. Find the measures of angles 1, 2, and 3. So just quickly looking at our picture, here's angle 1, here's angle 2, here's angle 3. Oh, and angle 4. In the given figure, knowing that M and N, lines M and N are parallel. So let's start with just trying to solve for x, since we know we need to know what x is, even just to find angles 2 and 3. 2 and 3 are same side interior angles. Which means that those angles are going to sum to 180 degrees. They're going to be supplementary. So we can solve for x by setting up 9x plus 9 plus 7x minus 5 equals 180 degrees. From here, we're going to combine like terms, simplifying the left-hand side of this equation. 9x plus 7x gives me 16x, and positive 9 minus 5 is positive 4 equals 180. To solve for x, we're going to start by moving the 4 over by subtracting 4 from both sides. So we get 16x is equal to 176. And then to isolate x, divide both sides by 16. 176 divided by 16 is 11. So now that we know the value of x, we can find angles 2 and 3 by substituting in 11 for x. So angle 2 is going to be 9 times 11 plus 9. The 108 degrees. Angle 3, now angle 3, we could plug in x equals 11, but we know that 2 and 3 are supplementary. So we could do 180 minus 108, which gives me 72 degrees. We know that angles 1 and 2 are vertical angles. So those two angles have the same measure. So angle 1 is also going to be 108 degrees. Looking at the relationship between angle 2 and 4, 2 and 4 are corresponding angles, which means they have the same angle measure. So 2 and 4, which means angle 4 is also 108 degrees. Now, there are other ways that we could prove these various angle measures once we found the measure of angle 2, but this is just to illustrate a couple options.